Hey everybody, back to it again. We are now going to do a unit on surface area, pyramids and cones. Once again loaded up with vocab, but again I don't think there's anything here that you shouldn't be too familiar with, especially after our unit on prisms and cylinders. So the big question is how we were going to use what we know about pyramids to find their surface area, and same thing about cones. Again, lots of vocab, and you can follow along in our text, section 11.3. All right, so a pyramid is a polyhedron in which one face, the base, can be any polygon, and then the other faces are the lateral faces. And these are all triangles, and they're going to meet at a common vertex. All right, so you can check out the vocab. We've got a base that is right here. Bear with. There we go. Base. Not it that way. All right. So the base right there. All right. And then the lateral faces are the ones around the sides. And of course the vertex is the point on the top. Okay. Like prisms, pyramids are named after the shape of their base. So if this is a pentagon on the base, what we have here is a pentagonal prism. All right. Now important stuff to keep track of here. The blue line in the diagram represents the altitude, okay? And the height, h, is the length of the altitude. Now, a regular pyramid is one that has a base that's a regular polygon. All of the lateral faces then are congruent isosceles triangles. And also in a regular pyramid, the altitude intersects the exact center of that base. So we have a hexagonal pyramid represented here, and the altitude in the blue line cuts down to the center of the hexagon. Okay. Notice also the green line. That is called the slant height. It is the altitude of the triangles, since they're all the same. It's the altitude of the triangles that form the lateral area, all right? So it's actually going to form a nice little right triangle. Notice that we have this depicted here in right, nice little, change colors on that black. Nice right triangle that's formed by one leg being the apothem of the hexagon, the other leg being the height of the pyramid, and the hypotenuse being the slant height. Okay, so you're going to use that a lot in terms of solving for either the slant height or the height of the altitude, or maybe even the apothem, depending on what the problem gives you. Just know you can pull out the Pythagorean theorem. Most likely, sometimes it may involve trig, but most likely the Pythagorean theorem in order to figure out some of these heights. Okay, so I think that covers that section there. Now, getting to the surface area of a pyramid is going to be the sum of the area of the base. Okay, so whatever the area of the hexagon is there, plus the area of all of the sides, the lateral area. All right, so base plus lateral area gives us the surface area of the entire thing. Now, what's cool is the lateral area again. If you look at these, we've got triangles that are all formed with the base being the side, and again, we're talking about a regular hexagon here. So all of these triangles are congruent again. So we've got 6 of these triangles, and all of them have an area of 1/2 the base times the height. But again, when we add those 6 bases, we get the perimeter of the hexagon. So we can simplify the lateral area to be 1/2 of the perimeter times the slant height. Okay, so once again, let's throw a slant height up there. Okay, so that green line represents the slant height, L, and our formula has changed now to become that the surface area for any pyramid is going to be the area of the base plus the lateral area, which is 1/2 of the perimeter of the base times the slant height. All right, cones, pretty much the same kind of thing, except our bases are circular. All right, one face is a circle. The rest of the points now also converge on a certain point that's called the vertex. All right, the lateral area is composed of the cone part, and we can show you in that later if you want to see that. But anyway, shortening it down to make this as easy as possible, the radius of the base, once again, is going to form a right triangle with the height and the slant height. Okay, so you can see that right triangle right there. That's also going to help you in solving for problems. And what we end up finding is that the surface area of a cone, still the base times the lateral area, but of course the base is pi r squared. Lateral area can be simplified to pi times r times L being the slant height. Okay, this happens to be a right cone. All right, again, that height, the altitude and the base are perpendicular lines. The altitude intersects the circle at its exact center. So for a right cone, we've got some special extra properties there. Notice also that pyramids and cones don't have to be right. They can also be oblique, and that causes us some other problems, but we won't be doing a whole lot with that sort of a mess. All right, so just to summarize, what we have when we're figuring out surface area, for a pyramid, base plus 1/2 perimeter times the slant height. For a cone, cancel that. For a cone, we have the area of the base, which is pi r squared, and the lateral area, pi times r times L times the slant height. Okay, now I'm going to skip to the end here. We're not going to do any problems here, just mostly because I don't want to make the video too long, but I do strongly recommend you look at the examples in the book, especially examples number 2 and 4, because they're going to give you some demonstrations on how they're going to use the Pythagorean theorem to find out different parts based on what's given and what you need. So I think this will do it. We'll work on this tomorrow. Have a good night, guys.